Hello everybody, Chris Keating here. We're going to start off with some kinematics problems. This will be problem number one. We're going to start off with a rather simple problem. It's going to be a car that starts at the origin and moves with a velocity where the velocity vector is 10 meters per second in the northwest direction. And the question asks, how far from the origin will the car be after traveling for 45 seconds? All right, this is a kinematics problem. So let's write down our kinematics equations. Kinematics equations. The first kinematics equation states that the change in position, delta x, is equal to the velocity times the change in time. Now this is just the definition of velocity. Velocity is the change in x over the change in time. And if you just multiply both sides by delta t, you get to the first kinematics equation. The second kinematics equation is that the change in velocity, delta v, is equal to the acceleration times the change in time. And again, this is just from the definition of acceleration. Acceleration is that delta v is over delta t. It's the change in velocity over the change in time. The third kinematics equation is the change in x, the change in position, when you don't have a constant velocity, you have an acceleration. So you're going to have some initial velocity, delta t times delta t, plus 1/2 a delta t squared. All right, it's a little more complicated because there's acceleration, right? Very similar to this equation number one, except in this one you have an initial velocity, and then that velocity is changing with a certain acceleration here, a. And then there's the fourth kinematics equation. This is the no time equation. It states that the final velocity squared is equal to the initial velocity squared plus 2a delta x. All right, so if you have a problem and it doesn't have time, you notice all three of these equations have time in them, this is the only one that doesn't, then this is the only equation that will work. This is the no time equation. All right, so now that we've written down all four kinematics equations, let's figure out which equation works for this problem. So in this problem, it gives us the velocity. So let's write what we're given here. We are given v is equal to 10 meters per second. And we're given the direction too, so we're given the vector. It's in the northwest direction. And then we're told that it travels for 45 seconds. So we're given a delta t, change in time, 45 seconds. And what do we want to find? We want to find how far from the origin the car will be after that amount of time. So we want to find basically delta x, the displacement. Now, if we're given these two things and we want to find this thing, which equation do we need? Well, we need number one. So we need delta x is equal to v times delta t. Pretty simple. I wrote down all four equations because you don't know which equation you're going to need necessarily when you start the problem. So it's good to have all four equations in the back of your mind. If I just told you, oh, it's this equation, then if you had to do it on a test, you might not know which equation. There's four equations. You might get confused. So it's good to have all four kind of in the back of your mind written down somewhere. All right, so let's figure out what delta x is. So v is 10 meters per second, so let's plug that in. And then delta t is 45 seconds. So delta x is equal to 450 meters. And we can box that as the answer to the question. Now, it does state that it was going in the northwest direction, so if you plot here an x and y, you might think, okay, this is going off in some 45-degree angle this way. That's not necessarily the x direction. So why did I use delta x? It's because you can just sort of rotate this all the way around in your mind. And since it's really a one-dimensional problem, you can call this the x direction, right? And then you don't have to worry about doing sines of 45 degrees, cosines of 45 degrees. Of course, you could do that. This is 45 degrees, and this is 45 degrees. And you can take, the sines and the cosines of 45 degrees. You get the square root of 2 over 2. And then at the end, you'd have to do, the magnitude of this squared plus the magnitude of this squared to get the total distance, displacement. But you get the same answer. It's going to be 450 meters. And that would just add extra complication to the problem. Since it's one-dimensional, we'll just call that the x direction. The northwest direction is what I'm going to call the x direction to simplify the problem. And so this is a pretty simple problem. I hope you found that helpful. Have a nice day.